you're assigned number 13. We have number 14 as an example. You are asked to determine if something's continuous using the definition. That means that you have to use the definition of continuity. And the definition of continuity in your book by Stewart is that the limit of f of x as x approaches a has to be f at a. Well, that's not very useful. I had a Venezuelan friend in graduate school who struggled with English, and he'd always ask me to look over his papers before he submitted them. And he had put a word called checkability. Like, there's no such word. And he's like, but I want to use that word. Well, we're going to use Ugo's word, checkability. And so I made a little checklist. The first piece is that I need the left limit and the right limit to equal each other. And I also want that second part, that limit actually turned out, if this equals each other, then that limit exists, and that limit has to be the same thing as plugging in the value a. So what that does, it splits apart. This is the jump discontinuity piece, that if the left limit doesn't equal the right limit, then it's jumping. And if it's not jumping, I'm not allowed to put a dot somewhere else. And so this avoids the dot somewhere else. So I'm just checking them off. If I look over here at number 14, the only place I have a problem of not plugging something in is -1/2. But they didn't ask me about -1/2. They asked me at 2. There's no issues at 2. So I can directly plug in the left limit and the right limit will equal each other, check. And I can actually plug in the value of 2, and I'm going to get 14/5. And so number 13, you have a polynomial. That doesn't have any issues anywhere. And so you should be able to check. But you have to explain that there's no jump, and I can actually plug in this x value with no issues, and I get the y value out. So both of them have to be satisfied to be continuous. So that's what you would do in your explanation on number 13.